Good afternoon, sir. Good afternoon, everyone. Today we are going to give a presentation on interpolation. The title for our presentation is Application of Lagrange's Interpolation Formula in Computer Science. Introduction. Now, interpolation is a method of fitting the data points to represent the value of a function. It has a various number of applications in engineering and science that are used to construct new data points within the range of a discrete data set of known data points. It can be used for determining a formula of the function that will pass from the given set of points xy. The number of data points obtained by sampling or experimentation represents values of functions for limited number of values of independent variable. This method is always needed to compute the value of a function for an intermediate value of the independent function. In short, interpolation is a process of determining the unknown values that lie in between the known data points. It is mostly used to predict the unknown values for any geographical related data points such as noise level, rainfall, elevation, and so on. In this presentation, we are going to discuss the meaning of interpolation in statistics, its formula, and its uses in computer science. Next, we have the interpolation function. The various data sets for x and y axis are given, and we have plotted the data sets in the two-dimensional xy plane as shown. Next, by connecting the data sets, we obtain the curve and we name it as p of x as shown. The corresponding x coordinate uh, with the x-axis is uh, plotted on the curve as shown. The corresponding y-axis, the corresponding y-coordinate for the y-axis is also plotted on the curve as shown. Now the Lagrangian polynomial. The Lagrangian polynomial form for this data set p of x is given as shown. The degree of the polynomial n equal to 3. The number of the points in the data set should be n plus 1. The combined or final formula is also shown in this slide. Now Lagrange's interpolation formula is also shown, and the general form is also shown in this slide. The algorithm. The algorithm is a combination of two formulas, and the resulting formula is also shown. Now we can find the intermediate values uh, uh, from the example as shown. From the data in the following table, find the value of p of 50 by using Lagrange's interpolation. The corresponding x and y values are given. Using Python, we can uh, see the corresponding y value of uh, x equal to 50 in the next slide. Here we can see that by uh, giving input x equal to 50, we get corresponding y value equal to 66.947656, and we can verify it with the help of the given table. Hence, we take x equal to 20, for which the corresponding y value uh, received from the program is 48.6, and for x equal to 80, we get y value 74.8, which uh, which is an exact match with the given table. Now the uh, curve is obtained as mentioned before, with the help of the data points and connecting them uh, to obtain the curve. Now, uses of interpolation in computer science. Different uses of interpolation in computer science can be seen with the next slides. Uh, First is a function approximation. In computer science, Lagrange's interpolation formula is often used to approximate the values of a function at intermediate points. This is particularly useful when the function is complex and its exact expression is unknown. Next is graphics and animation. In computer graphics and animation, Lagrange's interpolation formula is used to generate smooth curves that pass through a set of control points. For example, it can be used to create Bezier curves, which are widely used in computer graphics. This technique is commonly used in computer graphics to create smooth curves for 3D models, animations, and video games. Gaming. One way Lagrange's interpolation formula can be used in gaming is to smooth out player movements. For example, in a racing game, if the player is driving a car on a track, the game can use Lagrange's interpolation formula to smooth out the motion of the car, making it look more realistic and less choppy. This can enhance the player's experience and make the game more enjoyable. Another way Lagrange's interpolation formula can be used in gaming is for character animation. In a game where characters move around, the animation can be created using Lagrange's interpolation formula to make the movement look more fluid and natural. This can help to immerse the player in the game world and make the characters feel more lifelike. Additionally, Lagrange's interpolation formula can be used in game physics to simulate the behavior of objects. For example, if a game involves objects that move through the air, such as projectiles, Lagrange's interpolation formula can be used to approximate the path of the object based on its initial position and velocity. This can be used to make the game more realistic and challenging. Another application of Lagrange's interpolation formula in gaming is in camera movements. In a game, the camera's position and orientation can change dynamically based on the player's actions. Lagrange's interpolation formula can be used to create smooth transition between different camera positions and angles, making the game more immersive and enjoyable for the player. Next application is cryptography. Lagrange's interpolation formula is used in secret sharing schemes, where a secret is divided into multiple shares and each share is given to a different party. The parties can then use Lagrange's interpolation formula to reconstruct the secret if they combine their shares. Then, error detection and correction. In digital signal processing, uh, Lagrange's interpolation formula is used to interpolate missing or corrupted data points. This can help in error detection and correction as missing or corrupted data points can be replaced with interpolated values. Next application is data compression. In data compression, Lagrange's interpolation formula is used to compress data by approximating a large set of data points with a smaller set of points that can be reconstructed using the formula. This technique is used to reduce the storage space required for large data sets. Next application is signal processing. In signal processing, Lagrange's interpolation formula is used to interpolate missing data points in a signal. This technique is used to smooth out signal data and make it more readable. Next application, digital image processing. In digital image processing, this formula can be used to reconstruct missing or corrupted pixels in an image by estimating their values based on the surrounding pixels. Interpolation is commonly used in image resizing and zooming, where new pixels are added to an image to increase its size or resolution. By using Lagrange's interpolation formula, digital image processing algorithms can generate smooth and visually appealing images even when working with limited or incomplete data. Then we have numerical analysis, data science, and machine learning. Lagrange's interpolation formula is a powerful tool widely used in numerical analysis, data science, and machine learning that allows us to estimate the value of a function at an arbitrary point based on a set of known data points. In numerical analysis, it can be used to approximate functions, solve differential equations, and integrate functions. In data science, it can be used for feature engineering, data imputation, and smoothing noising data. For example, Lagrange's interpolation can be used to fill in missing values in a dataset or smooth out noisy time series data. In machine learning, Lagrange's interpolation can be used to construct decision boundaries and interpolate between training examples to make prediction on new data points. Conclusion: overall, Lagrange's interpolation formula has numerous applications in computer science and is an important and very powerful tool used for many mathematical, statistical, scientific, and other computational tasks. Thank you very much.